Hello, good afternoon, everyone, to the Financing of the Energy Transition online workshop. Great to see such a highly knowledgeable expert panel throughout the 2 days of our online conference. And thanks to the British Embassy and to the Hungarian Economic Association for co-organizing this event with us at Cambridge Econometrics. This event is really focusing on 2 days on 4 different topics. And yesterday we had the topic of the sustainability-linked finance. We discussed the differences between the green and the sustainability-linked bonds, the emerging taxonomies. And we all agreed that sustainable finance is really here to stay. It will become part of the business as usual. And in the meantime, we just have to be very mindful of the risks and opportunities that this poses. And although there is a growing investor base in Hungary, there is still limited offerings and low volume of products in also ESG in Hungary. And then this morning, we talked about the decarbonisation of buildings. There again, we discussed what are the differences between the landscape in Hungary and in the UK. And we could see that in the UK, there is the use of public funds. So government-backed funding is definitely needed and indispensable to accelerate and scale up the renovation of the old and inefficient building stock. And not only the energy spending is a higher share in the household spending in Hungary, but also there are less savings to finance these investments. So these were the key takeaways from the earlier 3 panels, and a discussion focusing on how transition plans are very much needed, as setting net zero goals without pathways is really not sufficient and will not lead us to the desired outcomes of decarbonization. So with this, I would like to welcome everyone on this panel focusing on renewable energy, and very much looking forward to hearing from you, hearing from the UK, the best practices and examples, and then focusing on the Hungarian landscape. And with that, Claudia, I would like to give you the floor, and thank you for being here.
Thank you, Dora, for your words and this sum up of what happened so far in this very interesting event. So before starting with the panel discussion, I would like to give the floor. We have 2 keynote speakers today now presenting the renewables and the hydrogen landscape in Hungary and in the UK. So I'd like to welcome Ede Borbély, Head of Renewables and Energy Efficiency from MOL, and Simon Cooper-Searle, Head of Hydrogen Strategy Department for Business, Energy and Industrial Strategy. So welcome, and I'd like to give the floor to Ede for the first keynote speech.
Thank you, Claudia. Let me share my screen. Yep. Let me know if it's not working, but I think it's functioning right now, and you can see the whole screen. So thanks a lot for the introduction, and also thank you for inviting me to this very great conference. My name is Ede Borbély, and I'm the Head of Renewables and Energy Efficiency at MOL Group, which is a regional oil company here in Central and Eastern Europe. And today I'm going to talk about our green investment considerations in the region, but also focusing on Hungary. Starting with the cost of different renewable energy technologies, I think in the last decade the picture is pretty clean. The photovoltaic and wind technologies constantly went down in the levelized cost of electricity. And what we show here, of course, there are like global figures, and onshore and offshore wind is blended together, but I think it shows the big picture well, which is that whenever it's possible, wind and PV, so solar technologies, are producing one of the lowest and most affordable energy out there. Of course, there are a lot of times and instances when it's not possible, when the sun is not shining and the wind is not blowing, but when it does, the picture is very clear. And the reason for this is twofold. Both the technology faced some very critical advancements during the last decade, but also the capital cost requirements for these technologies contributed a lot to their lower levelized cost of electricity. If we go to the strategic considerations of a big industrial conglomerate such as MOL Group, we can say that these big conglomerates and industrial companies are in the best position for renewable energy deployment, and there are like 3 reasons for that. First of all, the power consumption of these companies are immense, and our units are one of the biggest consumers in the region. The second reason is that the market prices for electricity and for own electricity generations are pretty good right now, and the outlook is also a lot more positive than it was like 5 or 10 years ago. And the third reason is that these companies, these conglomerates such as MOL Group, are the asset operators of today. And if you want to be the asset operators also tomorrow, we have to invest in all those critical infrastructure, which will dominate the decades to come and will be the engine of the green economy in the region and also globally. On the right-hand side, you can see that that solar PV and the wind investment show an anti-cyclical load factors. This is simply meaning that during summertime there is more sun than wind, and during winter time there is more wind than summer, to put it like very plainly. So based on this, and also based on the cost figures, what I just demonstrated in the previous slide from Magyar, we think that PV and wind should be the backbone of a major renewable portfolio of such conglomerates. If we look back into our renewable investments, what we made initially in 2016, and we have functioning power plants since 2019, we can say that we've learned a lot from these investments. We've learned a lot from the operational maintenance. We realized that there are a lot of synergies in our industrial operations in these technologies, and these technologies also have a positive employment impact locally on our sites throughout the whole country and throughout the whole region. Another important consideration, what we learned, that managing the balancing cost and optimizing the balancing cost of these renewable technologies is a very strategic area, and this will be the prime profit driver for these renewable technologies also in the future. And the third thing is that in non-feed-in premium regimes, we require PPAs, so power purchase agreements. So we have to have a very extended trader portfolio who can provide us with these PPA, and who can also secure the competitiveness of our investments. So as a result of our Hungary investments, we also decided to expand to Croatia. And these 2 plants, what you can see on the map with green dots, will come online in the first quarter of 2023. If you look at the regulation and also the other core countries, we can say that Hungary was quite a front runner in terms of the solar photovoltaic investments, both in terms of regulating them with subsidies, and also with price regimes, and also deploying them. What we see is that on top of the currently operating 3 gigawatts of capacity in the country, 5 will come in the next years. So there will be a quite significant bottleneck from network connection side, which will really test our ability that how can we integrate these sources successfully into the power system. In Slovakia, we see smaller EU RRF tenders, and also network integration bottlenecks and debates, which are still going on, which have to be overcome to make these investments successful. And in our Croatian market, we made our investment purely on market basis, so we are not applying for any kind of subsidy in Croatia, and we are very excited about our investment in that country, and seeing that how these investments will make it on the free market. And probably just one last slide about energy efficiency as well, because there was a focus of green investments in the title, and I thought that energy efficiency investment is also a very worthy subject to talk about. And the reason is because we think that the greenest energy is the energy what we are not consuming, and this is a very simple sentence, but I think it's also very true. In the past, we executed various energy efficiency projects within the group, and we also have enough knowledge based on this. And when these energy efficiency obligation systems are coming into place, either connected to the corporate income tax, either connected to the sales of energy consumers, we can utilize a lot of already existing projects and knowledge from the group. And here I put some major projects, for example, heat exchanger replacement, tank installations, electric vehicles, and gas boiler renovations, where we see the biggest potential in energy efficiency in the industrial context. And this is a slide just to demonstrate that what have you learned from this investment. And with this, I would like to thank you for your attention.
Thank you, Ede, for your presentation, for this overview, not only about Hungary, but also about the operations in Croatia and Slovakia, because I think I will be never tired to say that cooperation is key when it comes to decarbonization. So it's very important that you mention also other countries as well. And thank you for setting the tone for the discussion that is about to come. So now let's move to another important aspect of the energy transition, which is hydrogen. And I'd like to give the floor to Simone for her keynote speech.
Great, thank you very much. So hello everyone, I'm Simone Cooper-Tell. I'm head of the hydrogen strategy team here in the UK at the Department of Business, Energy and Industrial Strategy. If you could move on to the next slide, please. That's great, thank you. So we in the UK see a really important and significant role for hydrogen in the future UK energy system. And that is because we see it playing a role in providing energy security, supporting economic growth and employment, and also as an important part of our journey towards net zero by 2050, which is a legally binding commitment in the UK. And the reason why we see it as a critical component in our journey towards net zero is that the use of hydrogen, which is a low carbon gas, will be an important complement and alternative to electrification. So we see it playing an important role in decarbonising heavy industry, particularly where there's high temperature processes. And also we know that it can provide a flexible source of energy, which can be used in the power system for different modes of transport and potentially for heat in buildings. We think that the UK is well suited to realise these opportunities for hydrogen because of its geography, its offshore wind capacity, its former stores of natural gas offshore, and also its infrastructure, not least because it has a large gas grid currently, which could be, in theory, transitioned over to hydrogen. So overall, there are lots of elements that means that the UK is particularly well suited to developing the option of low carbon hydrogen. And in the strategy, we have set out an ambition of 10 gigawatts of low carbon hydrogen production capacity by 2030, with at least half of that coming from electrolytic hydrogen, which is sometimes referred to as green hydrogen. I've signalled that we see this both as an emissions imperative, but also an economic opportunity. So studies that we've begun to do around this have indicated that there's an opportunity to transition high carbon jobs and also unlock significant co-investment from the private sector. So we recognise that there's huge potential for hydrogen, but actually I think it's important to signal that we're starting from practically zero. And so in order to make this happen, the strategy set out quite a number of commitments and action across the entire hydrogen value chain. So the strategy outlines around £1 billion worth of government support for hydrogen and other low carbon technologies. Of that, around 400 million is on hydrogen specifically. There was a lot of detail in the strategy and in subsequent documents around the support for hydrogen production. And so I'll be talking a bit more to some of this later. The flagship scheme is this hydrogen business model, which will provide revenue support. There's also £240 million of CapEx co-funding for new hydrogen production plants, and a UK emissions standard for low carbon hydrogen. So any new production facilities will need to demonstrate that it is sufficiently low carbon, and that threshold is set by the standard. The strategy as I said, we're starting from practically zero, so it sets out the plans for how the UK will support demonstration and deployment of hydrogen for applications across different sectors of the economy. And I've already mentioned that we see this as both an emissions imperative and an economic opportunity. So if you could move on to the next slide, please. So I'm just going to touch briefly on some of the activities that we've set out across the entire value chain. So starting with production, I've signalled that the UK is supporting multiple production routes. So as long as it is sufficiently low carbon, and this means CCUS-enabled hydrogen as well as electrolytic hydrogen. And we see an important role for CCUS-enabled hydrogen, sometimes referred to as blue hydrogen, as a way of achieving scale early on in the development of a hydrogen economy, just because the volumes of blue hydrogen is so much larger than through individual electrolyzers. So on the route to meeting our 10 gigawatt ambition by 2030, we planning and policies are in place to support up to 1 gigawatt of electrolytic hydrogen and 1 gigawatt of CCUS-enabled hydrogen by 2025. Production is very important to set up, but actually the whole value chain needs to be developed in tandem. There's absolutely no point in having production facilities if they're not connected to a network, and there's no transport and storage facilities in hydrogen as well. So we've recognized that we need to do a lot of work to scale up hydrogen network and storage infrastructure. And a key way that we will do this is by designing a new revenue support scheme, which we also refer to in the government as a business model for hydrogen transport and storage infrastructure. We see a role for hydrogen across lots of parts of the economy, but actually we're not being entirely prescriptive about where it should go. So we recognise that a lot of industrial users that rely on high temperature heating would want to explore the option of hydrogen. So there are industrial clusters in different parts of the UK, and we see these as important anchor sites for use of hydrogen. But the equipment used by industry needs to be hydrogen ready. And so we're exploring mandates and options and policies that would help to speed up equipment so that it's ready to use hydrogen. And that actually that needs to happen quite soon, so that any new investments from these industrial users can mean that they can purchase hydrogen ready equipment. We see a potential role for hydrogen in transport alongside electrification, and have issued lots of different funding supports and schemes and competitions for deployment of hydrogen in buses, HGVs. There's a lot of work going on and competitions around trialling the use of hydrogen and derivatives within shipping and also in aviation. The UK is interesting in that it is considering the option of using hydrogen for heat, in part because around 85% of all buildings in the UK are connected to the gas grid, and so hydrogen may have a role to play in decarbonising heat in buildings in the UK alongside established technologies like heat pumps and heat networks. And so there are trials going on at the moment to explore the option of using hydrogen for heat, and we'll take a decision on this in 2026. And finally, we see an important role for hydrogen in the power sector, both as a way of dispatching power and also in a role as a long-term, large-scale store of energy. So if you can move on to the next slide. So as I've signalled, there's a huge amount of work to build up the entire value chain, but an important and valuable output from the strategy was also a roadmap for how we see the value chain evolving out to the mid-2030s. And I won't spend a long time talking about this slide. I think the key takeaway is actually that this slide was co-developed with industry, and I think that was a really powerful and important approach, because it meant that both industry and government had a clear sense of what they were working towards together out to the 2030s. And actually, this can be an anchoring device both for investment decisions and also for policy development. The onus, obviously, on government is to develop an appropriate policy and market and regulatory framework to realise this roadmap. So if you could move on to the next slide. And so the strategy was met with quite a lot of enthusiasm, and actually there's a huge amount of interest and activity within the UK from industry and investors to try and make this happen. So this slide gives an overview of some of the projects that are being proposed in the UK to start deploying new low carbon hydrogen production facilities. And you can see that there's a mixture of green circles, which indicate electrolytic hydrogen projects, and blue circles, which are larger CCUS enabled hydrogen projects. And there's also efforts and plans around large scale storage and distribution of hydrogen. And it's really exciting because we're setting the strategy, we're designing the policy framework, and there's a lot of interest from industry. So if you can move on to the next slide, please. So I think an important thing that we realized very quickly after publishing the strategy is making sure that we have appropriate incentive mechanisms in place to incentivize the deployment and the scale that we need to see within hydrogen production, supply and use. And so a flagship policy that we've introduced is the hydrogen production business model. And so this is a revenue support scheme, and it's a CFD style support scheme. And if you look at the left diagram, this shows how we expect the CFD scheme to work over time. So it's very similar to other CFD schemes where you agree the strike price through an auction, and depending on the reference price, which is set by the market, government will pay any portion of that amount that isn't met by the reference price. So the amount that's below the strike price but above the reference price is paid by the government, and anything below the reference price is the revenue that would be received by the market. So that is how we expect the market to evolve and the CFD for hydrogen use to evolve. However, we recognise that currently there isn't a market for hydrogen. So actually, if you move over to and look at the diagram on the right, there's actually, we see this as how things might need to work in the near term. So rather than have a reference price for hydrogen, which is determining the variable played by government versus the market, we've set the floor of that as a reference price for natural gas, and then actually support for hydrogen from the government would only be paid above the reference price for natural gas. And then as and when hydrogen is sold to users, support only applies up to the price of hydrogen as it's sold. Ultimately, it's quite a complicated scheme, I'll be honest, and there's a huge amount of work and effort and that's going into designing something that makes sense. But ultimately, the intention behind it is to provide price certainty for hydrogen producers, and also to make sure that the price that it's sold at is not excessively high, so that users aren't penalised by too much by choosing a low carbon alternative to natural gas. So if you could move along, please. Thank you. So the business model, which provides revenue support, will work alongside the Net Zero Hydrogen Fund, which is £240 million of capital co-funding from the government for new hydrogen production projects. I think it's fair to say that given we're starting from pretty much zero, in developing the hydrogen economy, there's a huge amount of sequencing and processing that needs to happen across hydrogen policy, but also CCUS policy. And so there are two different routes for how hydrogen projects are funded in the UK, depending on whether or not you are following a CCUS-enabled route or an electrolytic route. So the CCUS-enabled route, different parts of the country have put forward proposals for a CCUS cluster in their regions, and so industry is sort of self-organised and put forward those proposals, and those were first submitted in 2021. Of that list, 4 of those proposals had CCUS-enabled hydrogen plants included in their proposal, which is a pre-combustion CCUS compared to post-combustion CCUS, which is used with natural gas. And then from that, we expect to contract around 1 gigawatt of CCUS-enabled hydrogen production from that shortlist of 4 projects. And issued the first competition in 2020 this year, and we expect to announce which projects are successful that we will provide capital co-funding for through the Net Zero Hydrogen Fund, but we will move to annual allocations. So there's a huge, as I said, there's a huge amount of sequencing that needs to happen to make sure that we've got funds in place and that actually these projects can move to final investment decision in time for us to meet that 2025 ambition. Finally, as I sort of signalled before, any new hydrogen production projects that are supported by UK funds needs to meet the UK low carbon hydrogen production standard. And that is currently set at 20 grams per megajoules of hydrogen. And this chart basically shows that across different production routes for hydrogen, we expect that this standard is challenging, but actually can be met through quite a few different production routes. So you can see on the left, that's electrolytic hydrogen, and actually some of the sort of next generation of autothermal refuelmers with CCUS can also readily meet this threshold for hydrogen production. So if you can move on to the next slide. Finally, I also thought it'd be worthwhile talking about our innovation funding. So the business model that I mentioned in the Net Zero Hydrogen Fund are focused quite a lot on commercially viable technologies that are ready for deployment. But actually, if we're looking to completely transition away from natural gas to hydrogen across different parts of the energy system, there's a huge amount of research and innovation that still needs to happen to bring those technologies up the technology readiness levels and also demonstrate first of a kind deployment. And so there's multi-million-pound funds across different parts of the value system that form part of the UK's £1 billion net zero innovation portfolio. So I've included hyperlinks here if anyone is interested on specific funds. So to summarise, we see hydrogen playing a significant role in the UK economy, and it could meet between 20 and 35% of final energy consumption by 2050, but we're starting from practically zero currently. The approach in the UK is to support both CCUS-enabled hydrogen and electrolytic hydrogen development. And actually the roadmap that I shared is a really important focusing tool for how we as government and industry expect the economy to develop. I've mentioned the low carbon hydrogen standard, and this is in place to ensure that any production is actually sufficiently low carbon to support our transition to net zero. And actually the support we're offering is a mixture of revenue support, which is the business model that I talked through, which is a CFD style, and CapEx co-funding. We have an interim ambition of 2 gigawatts of low carbon hydrogen production to be in construction or operation by 2025 and 10 gigawatts by 2030. And actually, we recognise that even if we put all of our effort into developing low carbon hydrogen production facilities, they will be stranded assets if we don't continue to develop transport and storage infrastructure in parallel and also support different parts of the economy to switch to low carbon hydrogen. So I'll pause there. Thank you for sharing the slides.
Thank you, Simone, very much for your presentation. I think we can learn a lot from the UK. I mean, as we learned a lot about the coal phase out, I think now it's the turn also of hydrogen, and you're starting from zero as a lot of other countries. So it's important that there is at least a real clear roadmap for that. So let's now move to the panel discussion, and I'll also introduce myself. I'm Claudia Patricolo. I'm the editor-in-chief of Synergy News, and I'm going to moderate this discussion about renewables. So going a little bit back to Hungary, I'm sure that you heard it a lot over the past couple of days that Hungary, when it comes to the energy transition, has a very good starting point, thanks to the rapid growth of PV, for example, and of course, its nuclear power. And we also heard during Eda's presentation about the growth of PV and the attractiveness of solar energy so much that Hungary actually anticipated the tender that was supposed to be in spring, and it actually started in November when it comes to residential solar PV. And I was reading, for example, the International Energy Agency analysis about Hungary, which was saying that since 2017, a lot of the country has increased its ambitions, and in 2020, it was the first country, one of the first countries in the region to put a carbon neutrality goal for 2050 into law. And also, companies, as we have seen in the MOL Group's presentation, are diversifying their portfolio, expanding a little bit more into renewables. And overall, by 2030, the country is aiming for a 90% of its electricity generation to come from low carbon sources. Will that be possible, and how? I think it's going to be one of the topics of this discussion. The International Energy Agency is saying that still the road ahead is very long, and there are many things that Hungary has to do. But overall, the director, Fatih Birol, was actually very optimistic, I have to say, because when speaking about Hungary, he said that, for example, there is also a huge opportunity for the country to develop hydrogen and for industrial sector. So especially those sectors that, as Simone mentioned before, are not easy to be electrified. And it is also important to continue investing in solar PV, but also in other technologies and sources like in wind and in geothermal energy. So overall, Birol was saying that Hungary possesses all the technologies that are needed to advance the transition toward a clean and more secure energy system. But then sometimes one thing that a lot of people say is missing is the money. So how do we finance all this huge transition? And I would like to welcome my fellow panelists for this discussion today on this virtual stage. So I'd like to start with Attila Assodi, a full professor from the Department of Nuclear Energy from the Budapest University of Technology and Economics. Welcome, Attila.
Hi, Claudia.
Then we have, yes, we can hear you and we can see you. Then we have Anita Shimon, Deputy CEO for Sustainability and Circular Economy at Alteo Group. Welcome, Anita. Laszlo Szabo, CEO of the Regional Center for Energy Policy Research, REC.
Hello, everyone. Hello.
And Edward Jones, Senior Policy Manager from Energy UK.
Hello, everybody.
Okay, perfect. I can see all of you. I can hear all of you. So before starting the real discussion, I really like to hear your opinion about what we just heard from MOL Group and from Simone from the UK and the hydrogen strategy. And I'd like to hear your thoughts a little bit first, and then we can start also with unpacking the financing aspect. Laszlo, would you like to start?
Well, Thank you very much. I think these were very interesting presentations. I mean, from different point of view, because we have seen one company view, and then we have seen more policy oriented and more on the longer term of hydrogen. What you have to see, and what I would agree with the first presentation, is that we see a big transformation in Hungary, a huge development in renewables. Probably we'll have time to go into details of this development. And very recently, we see that with the very rapid development of renewables, mainly focusing on PV, we are already facing challenges connected to the integration of these renewables. So we might have to elaborate on that one. And of course, financing is a key issue here. So we are facing huge challenges. We are talking about gigawatts of capacities, even in a small country, which we have to develop and install. And of course, financing is a key issue here, which was to focus on, I think, in this panel discussion. So I'm looking forward to this.
Thank you, Laszlo. Anita?
I heard that it is a key issue, the PV, and I see it in practice as well. And according to the McKinsey's research, Hungary's solar generation capacity could be increased over the next 3 decades. By 2035, renewable can make up 79% of installed generation capacity. And this is always a key issue. How can we reach this goal? As I'm representing a new generation energy company, until we are so close to this issue, as we owns and operating a total of 26 power and heating plants. The portfolio represents more than 200 megawatt electricity production capacity, and more than 700 heat generation capacity. So we are very close to this energy transformation. And of course, we have renewable capacities like wind, solar, biogas, hydropower plants. So we are really expecting a growth in this field for the next decades.
Thank you. Attila?
Thank you very much. The introductory presentations were very interesting, and I do hope that we will have a very intense discussion in this panel discussion. Let me say that I agree with the fact that Hungary had in the last several years very intense development in the photovoltaic sector. And today we see real technical limits in that development. So there is a will, and there could be more interest to invest in that area. However, technicalities are limiting this expansion, and we have to develop control systems, other means to enable more photovoltaic into the system. In the current Hungarian energy policy, the target for you for 2030 with 6,000 megawatt photovoltaic and 12,000 megawatt photovoltaic in 2040. But I don't think that this would be possible without development of the grid and without large-scale storage and with other important developments in the system. So only investing into the photovoltaic panels or photovoltaic power plants will not work, I have to say this way. On the other hand, I think it is important to say that the main target is decarbonization. And for decarbonization, not only renewables, but nuclear is key as well. So Hungary is a nuclear country using nuclear power since the 80s. And by continuing nuclear production, the decarbonization could be much faster and much more effective. So it is a very high interest to keep the Paks 1, the current nuclear power plant, running, not only until 2030s, but even longer. And if we can invest, if we can finish the Paks 2 project or even more nuclear projects, this is only the possibility to reach really the 90% decarbonisation target of the electricity production. Only renewables cannot solve this issue in Hungary. This is clear. So the cooperation between nuclear and renewables is necessary in this area as well.
Thank you, Attila, for also mentioning nuclear, and Anita before mentioned biogas, for example, and then there is also the importance of energy storage. So yeah, it's not only solar PV. So let me close this round of thoughts, moving to Edward.
Yeah, good afternoon, everybody. I agree with everything that's been said so far. Those were two really interesting presentations. Thank you, both of you. It's great to get to see that. Simone touched on the CFD process that we used within the UK, so the contract for different process, and I'll speak a little bit more about that, on how that has essentially de-risked a lot of the market and allowing the UK to generate this capacity and increase it at scale, is what we've been able to do. And then I'll talk a little bit more about the lessons learned that Hungary can take and some of the processes that we've done through that. So I directly lead on nuclear as well, so I'll be happy to talk about that as well, Attila, as well as renewables generally, and also CCUS, so importance in trying to achieve our decarbonisation. So thank you.
Thank you everybody for setting the tone for this discussion. So I'd like to start with something that Attila mentioned. You mentioned these very important targets for solar, for example, by 2030. So my question now is going to be for Laszlo and for Anita. Is it realistic? Are these ambitions realistic to achieve in 2030? What else is needed then to get there? Already Attila was mentioning, for example, the infrastructure, the connection, the grid. But I'd like to hear also your point of view on that. And Laszlo, you can start with that.
Thank you. As I mentioned, we are really facing huge challenges here. The good thing is that we see that the investors and the developers from renewable part were really willing to participate in this process. And we were taking, first, of course, you are always taking the easy steps. And the easy steps is buying the panels and install them in the system. And it was a huge development. I think what we have seen, the auction system worked very well. We were really reducing prices. And we arrived to a point where in the auctions, photovoltaic was really there where the European other countries achieved the prices. So that was a great development, and I think it shows the forces of the market development we can achieve. At the same time, in the past half of 1 year, we saw the emerging issues mainly driven by the TSO and DSO companies, that there is a need for considering already the integration costs and the integration challenges which are facing at the same time. But you have to see this, that it was in an environment which is very volatile now. So I wouldn't say if we were not in a system where we see high price volatility due to the gas market development, really high prices in the power sector in all around Europe and even beyond. These together were putting high pressure on the system actually, and that's why what we have seen in the last few months and maybe even a year, that there is a sudden stop in having more renewable in the system, more PVs in the system. What we have to see is that there are the applications, there are more, we can more than double the present level of PV just by application. But of course, we have to see this other part, that the system needs more investments in the network at the DSO and the TSO level. We need more investment and more design element in the balancing markets, in the auxiliary services as well. And of course, there we would need flexible capacities at the same time. We have seen such development as well in auctions. For example, in Hungary, the last auction was designed in the way that PV generators had to install certain percentages of their capacities in storage technology, which is a development we have seen in other countries. So Hungary was already following this trend very closely, and very good step it was taking in this position. What we have to do, of course, and we have to see further. If you really have a look at the cost estimates, and we'll come back to these issues later, these are really high amount of money which we'll have to spend on improving the network conditions, ranging from 500 billion, for instance, up to even 2 or 3 times this one. So this money has to be there. We have to spend it wisely, and then it's a very good question whether the coming, because it's not even 10 years, but we have 8 years till 2030, whether that would be sufficient. But I think we can achieve quite nice development there in the coming years.
Before I go to Anita, actually, Laszlo, I would like to follow up on something, because you mentioned the volatility of this moment, the huge uncertainty that there is. Then if I think about the fact that the electricity demand is going to actually increase, especially if we don't have a lot of gas supplies, and then so we're switching more to electricity, but then the prices of electricity are quite high as well. So do you think the electricity market reform, it can actually work for Hungary? Is it going to be a good thing?
Any reform, I mean, a reform can go in a good and a bad direction. My opinion is that what Europe achieved in the last 15 years was a very nice development, but it was not 100% fully achieved. So if we would have been achieving what was written on these documents and in these plans, that would have been even nicer. And now we are facing some challenges, and the answers are sometimes really very harsh. So very strong answers to a strong situation, and it's always a question. I believe that some of these answers are good and would drive to a good directions, but some of these answers we really have to be careful, because we might be very easily destroying some results which we had worked 15 years over. And then just coming back to this high price level and volatility is that what is nice, and then it's reinforcing that the high price level is really helping renewables to get even a further impetus, further push and further increase in its share. But of course, everything has the price. So we have to design well-behaving support schemes, because if it's not well designed, it can be quite distorting and it can be very costly. The example which UK was bringing, the CFD type of support, is a nice example that we can do it right. We can even limit the consumer payments to this market and pay back some of the money which was paid by them before. And luckily, actually, the Hungarian support scheme, the renewable support scheme, is following something, a CFD type of scheme. So that's a good news in that sense, that with the high prices, we are limiting the payment by the consumers, actually. So that's good news.
Yeah, I'm sure the high prices are actually increasing the attractiveness for PVs. I see more and more people that before were a little bit skeptical for buying PVs because they are expensive when you talk about installing them. But then now the return of investment is much more interesting than the upfront cost. So now let's move to Anita. So from your perspective, from the current point, starting point of Hungary, how do we reach the renewables goals?
I think Attila mentioned very, very well before that we have to understand that the national power plants and nuclear energy will be part of our life for the future as well. We can't solve everything from the renewables. German government has approved the reopening of 16 fossil fuel plants, power plants in the past months. So we have to understand that renewables not just the solutions. we have to increase the volume of the renewables, and of course we understand that the solar PV is becoming the lowest cost option for new electricity generation in most of the world, which is expect to propel investment in the coming years. The average annual generation growth of we expect, I think, above 20-25% for the period of 2022-2030 is needed to follow the net zero emissions, which are necessary by the EU. We understand that it requires much greater policy ambition and more effort from the public and the private stakeholders as well, especially in the areas of grid integration. And I think grid is the key issue nowadays, because we can build up a power plant in 1 month, 2 months maximum. But what about the grid? It takes us more than a year to have it. So it's we have to focus about the background of the capacity. So of course we can build up many renewables, but what about the background? How can we connect them to the electricity system? That's the key issue, I think.
So how do we speed it up?
It's very difficult. We have to modernize the system itself, and I think each country has to focus for the improvement of the grid capacity.
You used a keyword, which is modernizing, which requires a lot of money. So I'm sure we can talk about it also later.
We are not talking about the lack of investments, of course.
Yes.
Claudia,
yes.
Can I comment on that?
Yeah, for sure.
Yes, sure, absolutely. I was going actually to ask you, so.
Yeah, okay, very good, thank you. So I think regarding the development connected to the PV developments, I think the grid development is extremely important. And surely for the large scale photovoltaic, you need good grid connection and a good grid to deliver the power to the consumers. But I think the problem what we technically face is not only the grid. So we see problems in the forecasting. And if you can imagine that if there is a big discrepancy in forecasting, then the balancing could be very expensive. And on the other hand, I think what we see right now is the real measurement of the situations at the different installations. So contrary to the usual conventional power plants, which are very well equipped and all the information necessary for the TSO are connected to the central dispatcher. In case of photovoltaic plants, this information is not available, and this limits the balancing and limits the safe operation of the grid. So I think development in the measurements, not only for large-scale solar but also for rooftop solars, would be necessary in the near future. I think it is really limiting nowadays the further development. And as last, let me mention storage, which will be important, extremely important. And here, not only the batteries, but other technology would be necessary. In the surrounding countries, there are large pumping storage hydro power stations, which can help in these situations. Unfortunately, in Hungary, we don't have any. And for those developments, I think even in Hungary, pumping storage hydro would be necessary and could help for photovoltaic and for other projects as well. So we have to consider this to reach a higher share of renewables and carbon-free sources in the electricity grid.
Thank you. So I'd like to, as we're talking a lot about now solar, I mean, Ed before mentioned also that there is wind, but I think that the high penetration in Hungary is for the PV market. So Laszlo, what do you think about these challenges that Attila and Anita were mentioning? And if there is anything that you would like to add?
Yes, I mean, just we talked a lot about the challenges. I fully agree with Attila on that sense that we should not think just in generation and flexible generation and storage technologies. There are some soft solutions as well, of course, because flexibility could be provided by consumers, so demand side can participate on one hand. On the other hand, we see that you have to separate the reserve market and the balancing market, and in the balancing market, actually, we have seen in Western Europe quite a nice development that once you merge the markets and you are not thinking of just national markets, in the balancing market, you can earn a lot of cost saving in these developments. So if you join these markets and then you participate in the platforms which you already see operating in Europe, then it can save a lot of cost for the consumers, because what we have to see at the end that all of these developments, well, maybe at the beginning will be paid by the utilities, but at the end it is the consumers who will have to pay the full bill. So we can, with nice financial instruments, we can spread these costs over a longer term, but it has to appear in the consumer's bill as well. So that's an important part. And as you mentioned as well, demand side and the increasing demand and electrification in Hungary as well, which is much faster than we saw before, because with the high prices, we see not only electrification of transport, but rather the more important part now is the electrification of heating, which takes place at a very rapid speed in Hungary as well. We have to consider that, okay, with this increasing demand, how can we spread this cost evenly on the consumer? So that's a really big challenge. And if we add to that it's not only electrification of heating, but in the energy policy of Hungary, we see developments like energy intensive sectors like battery manufacturers, car manufacturers arriving to the country at a speed we haven't seen before. We have to be aware that it is a good thing. We have more labor force, more value added, higher GDP, more income for the country, but at the same time it might mean a steadily increasing demand, which you will have to cover in the future. You have to take care of this coverage as well on a reliable scale, which we have seen in Hungary. We had a very reliable power supply up to now without big outages, and that's the plan for the future as well. So with these renewable development, with the intermittency and with the flexibility, we still want to and have to provide this steadily available power for the country and for the consumers.
But do you think that the consumers, they don't see like the long-term advantages? Because you mentioned spreading evenly the cost, so it is going to appear in the consumer's bill. So do you think that in these circumstances, would it be like better to pay a little bit more now to pay less in the future? Is it something that the consumers still don't see?
Well, you know the Hungarian electricity policy, and know if you speak about the household consumers, you see this split between the two groups. One group is that with rather lower consumption, which might not due to the higher energy efficiency. It might mean that low consumption because they have a small house, small flat, not because it's well insulated. And then there is the other group having a higher energy consumption, either electricity and gas, and we see the impact on this group. That twofold increase in electricity prices a minimum and 6 or 7-fold increase in the gas prices is a shocking one. So that type of situation we cannot avoid. I mean, increasing the price 7-fold from one year to another is really very painful and politically not too acceptable, mainly if it's not only impacting the large consumers, but really small and vulnerable consumers can be in this group. So somehow you have to treat this situation. It's a very difficult equation, difficult for Hungary, but in other countries as well. And I don't think that's a good solution, not to show the other group, the safe group who did not see that high increase in prices, that please, the energy which you consume is an expensive good. So be as kind and save as much energy as possible, because energy saving is the real tool to reduce your bill over the long term. So what we need to achieve is that this energy efficiency has to take place at a large scale. We see already the starting point, but what we have to realize that it has to be done over the next 5, 10, or even 15 years. So save all the energy which we can save, both in the household, in heating, but in the industrial scale as well. So that has to be a first priority. And price signals are quite good. So if you allow high price increases, that will have the impact on it, as we would see it in the gasoline prices as well, because now we'll see that it will move. It moved quite significantly lately, and it will have the impact on the demand, and all the people will adjust to that one. That's for sure. What we have to avoid, that it has to be, it shouldn't be too harsh and shouldn't be too sudden. So that's the policy challenge here, I think.
Well, I'm wearing 3 layers of sweater, so I'm doing my part with saving the electricity at home. Edward, what are your thoughts about these challenges that we just mentioned?
So obviously I'm not an expert on Hungarian grid or anything like that. So what I can talk about though is the challenges that we've had in the UK and the issue that we've had in bringing more renewables, more flexibility on to the system. So the UK grid is not very well designed. It's not effective in what it's trying to do. And that's because it hasn't updated and modernized as our renewable increases has changed over the last couple of decades. So that's obviously leading to a huge number of challenges that we've got, that as we bring on more renewables, particularly in Scotland, and try and bring them down to our locations such as London and Birmingham, when there's a much higher use of demand, that's causing a huge amount of issues in what we're trying to do. What we have got though is a pretty significant amount of nuclear capacity at the moment, which is anywhere from around about 15 to 20% of our daily capacity, depending on how energy intensive that day is. One of the concerns that we've got is that we're going to be deactivating 5 of our 6 nuclear reactors over the next 8 to 9 years, because they are advanced gas reactors. The graphite core has cracked within those, and they will ultimately have to be deactivated. So we're now looking at, how do we get that capacity, which is around about 6 gigawatts, from low carbon source that isn't nuclear, because we won't be able to build nuclear in that time. And where do we get it from? So I think Attila picked up on a number of comments, as did Laszlo, regarding storage, regarding PV and wind. So the UK isn't great for solar. We're okay actually, because everyone knows about the British weather and the British climate, hopefully, and it's not very sunny here. But
well, I got some burnt in London once.
Right. Really?
Yeah, so wow. It happens sometimes.
It can happen. It's not very. There's about 2 days of the year when it can happen. Yeah. So, but obviously, solar panels do become far less efficient when they get too hot. So there is the ability to use them quite extensively in the UK, but we're overwhelmingly looking at wind, because we've got the North Sea, we've got the Highlands in Scotland that receive a huge amount of wind, and what we're now focusing on is increasing the grid capacity and the ability to move that energy from where it's being produced to where it's needed. So that's one of the key lessons that Hungary really should look at, what we haven't been able to do, and what should be a priority is it being able to get energy from where it's generated to where it's actually needed, because that's one of the single biggest issues that we've got in the UK. So that's probably the main comment that I've got on it so far, that having all of the energy that you want is great, but if you can only move half of it, sort of a what's the point in having the other half of it? That's one of the challenges that we're having now.
Yeah, absolutely. And let me, you always anticipate me every time. So I was going to you actually.
Yes. Because Edward mentioned several very important points what I wanted to reflect to. So first of all, we made some analysis on the question how much wind could be incorporated in the Hungarian system. We have very limited capacities right now, only 320 megawatts, and in line with our calculations, over 1,000 or 2,000 megawatt wind could be incorporated into the Hungarian system. So here there is a potential, and I have to mention that based on the fact that wind is not in coincidence with solar, so from the grid point of view, a larger amount of wind is better in the current situation than even more photovoltaic without the developments that we mentioned in the previous round. The second point is that also mentioned the high gas prices are shocking. Shocking for the households and shocking for the institutions who have to pay the bill. Fortunately, we have several cities which have very well developed district heating system. And those district heating systems are fed right now with heat coming from gas. Here, the government decided to develop geothermal energy, which is right in several locations, but it is not the solution for all the locations, not for all the cities. I think here the small modular reactors could be considered, because small modular reactors could be implemented faster than the large-scale nuclear power plant. Edward mentioned that for large-scale nuclear projects, the time frame is critical, and they require 10 or even more years to be implemented. But maybe for SMRs, this time frame could be shortened, and the SMRs could have in district heating and could have substitute natural gas. Because in my view, with the crisis that we face from the war between Russia and Ukraine, we have to consider high gas prices for longer term. So we are searching for a solution not only for 1-2 years, but for the longer term. And we have to find the solution which is really sustainable on the long run as well. So I think here SMRs could be interesting.
But what about if we think about nuclear units? I mean, nuclear. Edward was mentioning some numbers for the UK, but in Hungary, nuclear actually guarantees almost 50% of Hungary's electricity supply. So it is actually quite big in the energy mix. So do you think is the future of nuclear in Hungary a long-term future, or is it something like more of a temporary measures, like the ones that Anita was mentioning before, like reopening the coal plants or the lignite plants? Is it the same thing with nuclear, or nuclear can actually balance renewables in the long term?
Okay, Claudia, here you have to be careful with the numbers, because so Hungary is a big importer of electricity, and our electricity import is approximately 30%. It means that the figure what you mentioned, this 50% nuclear share, is within the Hungarian electricity production,
yes.
not in the supply,
yes,
because of the high share of import. So if we look at this number on the level of consumption, electricity consumption, this is approximately 35-36% of the current share of PAX 1. And the government and also the parliament decided to extend further the lifetime of the current units. It means that PAX 1 with the 2000 megawatt production capacity will run most probably until the 50s. The other nuclear project what we have in the pipeline is the PAX 2, which is about the construction of 2 new units with the capacity of 1,200 each. I mean 1,200 megawatt. If this project will be finished and if we will have PAX 1 and PAX 2 parallel in the electricity system, they can cover approximately 50-55% in the consumption, because we assume increase in the electricity needs in the next 10-15 years. So this is why I'm saying that renewables plus nuclear could cover the needs in Hungary. So just to summarizing, PAX 1 and PAX 2 together would fit into the Hungarian system, and because of those developments, what Laszlo mentioned, I mean car production, battery production, we see so high industrial electricity need increase. Based on that, I could imagine even more baseload capacities could be constructed in Hungary just to comply with those needs.
Let me go to Anita then about this, because we are saying renewables plus nuclear plus energy storage. What's your take on that?
There are many points that we mentioned.
Yes.
There are many topics in my mind, but let's start with the geopolitical situation, which I think shocked every players, not just the industrial players, but the households as well. As a company, we realized that the industrial players understood that they need the renewables. If they are producers, they are working for the production sector, they have to decrease the amount what they are spending for the electricity. So it means that all of the companies started to think over how can they install PV solar possibilities in their plants. This is the first issue. On the other side, of course, it was a shocking period for everybody to face in the new prices of the electricity, because of course it's 10 times more than normally. They had to understand that they have to do something, and I'm not talking about sustainability, because it's not about sustainability, but it's a problem all facing with. On the other side, the households, we are focusing for e-mobility as well, which means that we are providing e-chargers for not just for households, but for offices, for big users as well, and for public and non-public users. And we understood that it's not about charging and not about e-mobility, but the storage of the energy as well is the point. So we are not just producing the energy and electricity, but we have to think over how we can store it and how can we use it on the most clever way possible. Altau has 11 megawatt capacity of storage capacity, which we use for primary electricity system balancing, balancing of the weather-dependent renewable power plants production. So we believe not just in the household levels, but of course in industrial level, which is our focus, that the storage, electricity storage, is the key issue for the future as well. And of course, on the other side, we have a virtual power plant, which ensures increased efficiency and continuing operating of our wholesale business. This power plant control center is designed to provide the capabilities for the central monitoring and the control of the small power plants, which is also the focus of our business. And in our portfolio, we have more than 900 megawatt renewable plants and capacities. So we know the problems of the producers with grid and how can they make the balancing and everything. And I think it's a complex problem nowadays, not just in Hungary, but everywhere in the world, that, okay, if we have the renewables, what can we do with it? Because we have to help the users to understand how could they use the balancing and how could they focus on the energy saving possibilities.
Thank you. So let's move a little bit to the financing aspect and see how do we pay for all of these. And I'd like to start with Edward. You mentioned this contract for different funding scheme that you're using in the UK to generate new renewables assets. So what exactly are you doing there, and what can Hungary take from the UK?
Yeah. Sorry about that. So Simone touched on this briefly when she was talking about hydrogen and the future of hydrogen in the UK. So contracts for difference, or CFDs, have been around since 2016 in the UK, and with each successive allocation round, or AR, the amount of contracts available has increased, so that the amount of renewables that can be awarded and the amount of money that can be awarded has been going up. Essentially, what it's been doing is, for each contract, it guarantees the so-called strike price, or the value price, for a megawatt hour of energy. So the most recent round was AR4, and renewable, in particular wind, got around about £45 per megawatt hour. So that means that for the next 15 years, the company operating one of these assets through a contract for difference will get £45 per megawatt hour for every megawatt hour they produce. If they produce less energy than that, the taxpayer pays up the difference, the government pays up the difference. And if they exceed that, if it goes to say £50 per megawatt hour, they would then pay that difference back to the government and therefore to the taxpayer. So what that means is that they have got a guaranteed price for 15 years or so, however long the contract is. So what this has done is has de-risked the market, essentially, because companies can now invest in that. They know exactly how much they're going to be able to get over the next 10 or 15 years, because the whole point of these contracts is that they're very, very long-winded. So what this has done, as I say, has massively increased the UK's capacity in order to be able to build these renewables. What they are also is they're decentralized from the price of oil and gas. So in the UK, our energy bills are related to the most expensive energy source that we're burning, which at the moment is gas, which is up at £180 per megawatt hour. Whereas obviously renewables are way down at the £40-45 per megawatt hour mark. So by having these contracts for difference, it means that people are actually paying that low value rather than having to pay up the very expensive because of the current price of gas. So that's the next perk that they've done. What they've done in AR4 is generated, I think a comment was made there that there's about 330 megawatts of wind in Hungary at the moment. AR4 awarded 7 gigawatts of offshore wind, just offshore wind, not onshore wind, but 7 gigawatts of that capacity was generated. So that will be built over the next 3 years to be providing straight into the UK grid. So we have 3 different pots for this. One is offshore, because it's such a huge amount of energy available that is processed by itself. We then have what's called an established technology pot. So this includes solar, this includes onshore wind, this includes waste, heat from waste. And then we have finally an emerging technologies pot. So this includes tidal, wave, remote island as well. So that is more expensive compared to other things. What it's doing is reinforcing that supply chain over the next few years. So as I'm sure everyone knows, the supply chain, not just in terms of oil, but from people capacity, people power and knowledge, to actually having the raw materials to build these assets, has really been struggled and strained over the last couple of years. So what the CFD allocation process is doing is making sure that there is still that chain available to companies looking to build on their current capacity. So what we at Energy UK, so we're a trade association, Energy UK, we represent the overwhelming majority of generators and suppliers in the UK, and then we take their members' views to BEIS, so not to Simone, because we don't really cover hydrogen at the moment because there is no hydrogen, but to BEIS and to government ministers, and try and push them in directions that represents what the market wants. One of those things is that CFDs do need to go quicker, and that's one of the things that I think Hungary should be taking away from this and observing, is how quickly there does need to be that transition from the current grid to what it needs to be for net zero. But it can't go so quickly that it destabilizes that the grid itself or that supply chain. And we actually need to make sure that what we're manufacturing is of high quality and meets the standards, that the people who are trained to be able to operate this are also trained to a high degree. We can't just have hundreds of thousands of people who sort of know what they're doing. We need 10,000 people who genuinely know what they're doing, and that's another key difference as well. So those are the fundamental things of what's going on in CFDs. So there'll be another round that will start at the beginning of next year, about March time 2023, which is called Allocation Round 5, and this will again look to increase even more the amount of energy capacity that the UK can build through these renewables. So one of the other things that we've now just done is approved one of our new nuclear reactors, Hinkley Point C, is now on one of these CFD contracts rather than generating power. So EDF, who operate Hinkley Point C, know that they will get £106 per megawatt hour for the entire length of that CFD contract, which is around about 15 years if memory serves. So that's obviously significantly higher than renewables, but we've got all the other perks of nuclear. So it's the base load, it's essentially 24/7 power, unless we have to, unless it overheats, and that kind of thing. So still a lot cheaper than gas, but we've got that guaranteed. So that's what the UK has done, and it's been very, very effective in achieving a huge scale up of the grid scale. But what the lessons are is how quickly you need to go is number one, and two, to have that supply chain and that built on. I believe that we're having a conversation on supply chain a little bit later, so I'll hang back some of my points for then. But those are the two key things that I think the UK has done well, but could be done better.
Really, I think it's becoming again a little bit popular, this contract for difference scheme, because also, for example, the European Hydrogen Bank that should be set up next year is going to be based on that. So apparently it should work, especially also for hydrogen, as Simone mentioned before. But let's hear what the Hungarian side thinks. You said a lot of times Hungary should take that, or Hungary should learn from that. So what Hungarians, the representative here, think? Starting from Laszlo, what is your take on these contracts for difference and other tools, like, for example, subsidies or PPAs and everything else?
Yeah. Thank you very much, Edward, for this, because I completely agree. One of the lessons which all European countries has to learn, CFD works much better than this one-sided premium schemes, because in this high price environment, this is really a very nice tool to take the burden away from the consumers, and then put some burden on the gainers, on the renewable producers as well. And the good news here is that Hungary usually takes, when it is coming on renewables, we were usually taking the German example, which applied this one-sided premium scheme. But in that sense, we were fast in learning, because in the auction schemes, actually we were going for the CFD. So lesson was already taken. What we have to learn from UK, I think, as well, is that what you have to see both for renewables, and it's true for nuclear, is that it's a very capital intensive. technology and investment. So you pay a lot for the technology and small amount for the maintenance and for fuel, which means that compared to fossil-based generation, it has a disadvantage. This financial cost is really crucial and critical. So you have to do everything to reduce this financial cost. So all the interest rates and the own capital has to be as low cost as possible. And one message which we should take from the UK and from some other countries as well, that really the best way to do that is to have a reliable policy looking on the long term and keep these promises and the policies in the pipeline. So don't do retroactive changes, because if you do that, you can burn yourself very easily. So you do it once or twice, and the investors will be very cautious. They would turn back to your country at a higher risk margin, and this risk margin would mean really higher cost for consumers. So that's what we have to take. I fully agree that actually what we have seen in Hungary, that in the renewable field till 2021, beginning of 22, there was no retroactive change, so it was a reliable market. We see the results, high uptake of renewables, but what we have seen in the last years, really very sudden changes, and some of them have retroactive ones. So instead of that, we have to learn that we have to announce this over a longer period, and then we should take care that the future investment will do whatever they need to do, but don't really destroy the business case for the earlier investments, because that's really a bad message for the long-term development. And I think it's fully true for renewables and for nuclear as well. That's a business where you think not only short-term, but really 20, 30, 40 years ahead, and then you have to keep this in the portfolio. So that's maybe another key lesson, and probably it is driving to the other issues which we have to cover, the financing as well. And in that sense, what governments has to do is that to keep this country risk and technology risk at a low level. So that's the other thing which I would take from the example of the UK and from other countries, is that follow this pathway. Announce it in advance, keep your promises, and have a long-term target. Don't change it every year, because then you make uncertainty in the market.
So can state subsidies help also?
Well, at the beginning it was needed. Actually, what you have to see is that in a world when we have these high prices, renewables at the moment, they do not need subsidies. So actually all these auctions and government decisions are rather on this, that who you allow to connect to the net, how much capacity you allow to connect to the network, what type of capacities. If you have a look at the example of Portugal and Spain, in their auctions, it's not that what is the subsidy which is needed, but how much these producers will pay into the central budget to have a license to get into the grid. So that's the situation where we are now. So instead of managing the subsidies, managing that, okay, who should come to the system, and usually you allow the cheaper, reliable sources and those who pay for the services. So those who pay for the flexibility provision, for the reserve capacities, and so on and so on. And the other thing what you have to see, that in this development we are really rapid, and we are in a phase. Hungary was not that good, but other countries, UK was much better, and some other countries even better, that PPAs appear as well. So the governments can withdraw in a certain sense from this market, because private companies and private contracts can appear in the system, and in other countries they appeared very quickly. In Hungary we were lagging behind in this development. We had the first real PPA only at the beginning of this year. We have 2 or 3 of them, because PPAs can be a nice solution, because the two parties can agree on many different conditions according to their needs, and there is no need for very direct governmental intervention. However, the government has the role to set up the rules there as well, because you just cannot leave this PPA market very alone, because just imagine these PPAs are asymmetric in a sense, because project developers like PV and wind developers, they made a promise and they build up these capacities, which will be there for 25 years. the buyer of the PPAs is an industrial companies, and we see now they can easily be driven out of the market in 1 or 2 years. So what will happen to these PPAs in that sense is a crucial question. So that is a real question, but PPAs is a very nice tool, so we have to do everything to allow the development of PPAs in the right direction, and probably UK has some more experience in that field as well.
Attila, your thought?
Yeah, this is a very economic question, so it is not really my field of expertise. However, I have to mention that I remember very well the times when the UK announced the CFD scheme for the Hinkley Point C, and for the whole CFD, because it is not only for the Hinkley Point C. You use it as a general tool in the market. So I remember those discussions, and there were a lot of critics. But I think your scheme is very good, and especially in the current market situations, you can really show how advantageous this CFD scheme is. The other comment what I wanted to make is that I remember also the times when Austria challenged the decision of the European Commission regarding the CFD scheme of the Hinkley Point C, and they went to the European Court of Justice and had lost this legal case. The court decided that the decision of the European Commission was right. And later on, regarding the PAX2 state aid case, Austria also challenged the decision of the European Commission, and they lost also. I mean, Austria lost this case as well. So I think the Hungarian government and the UK government was right by deciding those two nuclear projects, and we can see from the judgment of the European Court of Justice that the procedures what the European Commission followed in those cases were right. So we have to continue on that way. My last comment is that the PAX2 project is not under a CFD scheme. This is a direct investment of the government. This is also possible, especially for a small country like Hungary, where the resources are limited. And finally, you need such kind of large infrastructure project to ensure the stability of the grid and to ensure the supply of electricity for households and industry. So this is also possible if financing is available in the framework of intergovernmental agreement.
Edward, Laszlo was asking about the PPAs, and so what is the UK example regarding PPAs? I think you're muted.
I made it almost the whole way through 2022.
No.
That's disappointing. I don't actually know about it.
I hadn't said that today yet, so I was like, I was waiting for the person to say that too.
I'm not overly familiar with PPAs. That's not directly within what I comment on. So I'm probably not the right person to speak on that. Unfortunately, I'm very much just CFDs. Sorry.
Okay. So I'd like to hear. I don't know if Anita, you would like to comment also on the financing aspect. I mean, maybe from a company's perspective. I mean, who needs the financing?
Yes. Thank you. We have to understand that high energy prices requires higher financing capabilities. And I truly and completely understand and agree with the others that we need, for the investments, we really need the reliable policies and regulation. We need the fixed taxes. So the change of the taxes and new taxes are really killing not just the business, but the willingness as well. So I think the most important part is that the policies and regulations has to support this activity and this energy transition. That's my point as a company.
Thank you. So as we are getting almost to the end of this discussion, I would like to ask everybody if you could give like some closing statements on what have you learned and what can you teach when it comes also to financing renewables. And we can start with you, Anita. So.
Thank you very much, first of all, for the invitation. It was very interesting and informative for me because from the as a company, I can understand more about the sector. Of course, I'm watching it as a sustainability expert, but it's true that at the end of the day, we have to understand that sustainability issues are also the point, not just the electricity and not just the big picture, but I am focusing also on sustainability, so it's very important for us. Thank you.
Thank you, Attila.
Sorry, I had to unmute. Okay, so I think this was very interesting discussion. Thank you very much for the experience from the UK. I think the main message is that we need to take into consideration security of supply, and by saying that I mean continuous supply, because Europe has a long tradition of well-developed electricity grid, and all the customers are used to have a continuous supply of electricity, and we need it in the future as well. Therefore, renewables and nuclear and flexibility, these are the three main areas from technology point of view, which will be necessary in the next future. And we have to work on all three areas to keep the system running with lower carbon emission. And finally, we have to avoid somehow the increase in gas consumption, because gas is limited right now and it has very high price, and most probably it will have high price as well in the future. So we have to switch from fossil, not only because of the decarbonisation, but also because of the limitations of gas imports to the European Union. Thank you.
Thank you, Edward.
Well, I mean, I've learned quite a lot about Hungary's energy grid and capacities. That's been quite entertaining and really interesting to learn about, and the challenges that I think, as Attila was just saying there, that we're experiencing across the whole of Europe, and the lessons that we can learn from one another, ultimately to try and achieve, each company's own net zero ambitions and goals. And yeah, I very much enjoyed this conversation. Thank you for having me a part of it.
Thank you, Laszlo.
Okay, so maybe just 4 or 5 messages which I would take from what we have spoken about. And the first one, we did not emphasize, it appeared in some of the talks, that I think energy efficiency is the first one. That one I would put. So really we have to learn. We were in a very comfortable situation in the last 10 years, consumers, mainly households. We did not care about energy. It was cheap and we were wasting it. We should not do it again. We should learn it that over the long term, that's not a way forward. Second issue is coming what Attila was telling, security of supply. The keyword here is diversification, I think. So we have to have all the eggs in the basket. So we have to see that, okay, which is the next technology which we would like to see in this basket. Not only photovoltaic, I would like to see more wind generation with the nice big advantages that it can produce on a larger scale, on a more balanced manner that it would produce similar or even at higher level in winter time when we need the energy compared to photovoltaic. And we did not mention that it has a big advantage compared to PV is that it's not the market value of this technology would remain at high level, while with the PV with higher penetration, it would reduce its market value because it would produce in those hours when they can produce together. So that's a big, so diversify and consider, of course, other sources. Nuclear can be included, and of course, maybe some gas still would remain in the system. However, the biggest question mark is on that one because we don't know what will be the price of gas in the future. So that's the most questionable part, that if you want to make an investment in gas-based generation, that is the most difficult business now, because it's very difficult to tell what will be the price of the input for that. What will be the price next year, in 4 years' time, in 10 years' time? So difficult decision. So that's the second issue. And the third issue is that in most technologies, what you have to do is that to make sure that it comes in the lowest cost possible. Sure, for renewables, have to do for the other technologies as well. There are the market tools on which you can use it. I mean, you can do it with auctions to get this technology into the system. But the big question is that because we see that lots of money we have to spend on the network and on the integration cost, there we have to see that how can we make it in a cost-efficient manner, because it's not 100% sure that we have to develop hundreds of megawatts from battery storage, but there might be other solutions. So we have to allow a competition there to see whether it's battery storage or other storage or some software demand-side management type of tool. Other tools are there in the market. So we have to ensure that this other part, the integration and flexibility provision part, will come on in a competitive way, allowing the least cost solution in the market. So that's the 4 or 5 points which I wanted to make.
Thank you. Thank you, Laszlo. I think that I can summarize this discussion with 4 C's. And one, it's not me. And I think, first of all, is the commitment, because I think that everybody needs to be committed. So we have the government, the industry, the consumers. Commitment is quite key. And cooperation. We have learned a lot from the UK, and hopefully also Hungary has something to teach to other countries as well. What Laszlo mentioned, so cost efficient, all this transition must be cost efficient. And then lastly, I would say a combination of things, because all the tools that we mentioned during this discussion are important, and there is not one single solution that is valid for everybody. So thank you very much for participating. Thank you for our speakers for your insights. And I'd like to give the floor back to Dora for your conclusions.
Thank you. And thank you for this fascinating panel that I think we should have named not renewables, but non-fossil solutions, just basically based on what we discussed. And thank you, Simone, for telling us about the UK hydrogen strategy. And thank you, Ede, for the industry decarbonisation and listening to the panel. And I did wrote down quite a few takeaways as well, and what we can learn from the UK. Having a reliable policy environment is definitely needed, and maybe, I don't know how to frame it, starting with a C, but I will come up with that, and we will write up policy recommendations based on all the 4 panel discussions, and those will be available on our website. And thanks a lot for your time and this